Boilers. Boiler is also known as steam generators. It is a closed metallic vessel. In the boiler, water is converted into steam above atmospheric pressure by the application of heat. Fossil fuels are the source of heat energy. The higher pressure steam is used for driving prime movers like steam engines or steam turbines for power generation. It is also used for producing process steam in textile industries for bleaching, etc. In other industries like paper, sugar, paramedical, and chemical industries. Boilers. Requirements of a boiler. Steam must be delivered at the required temperature, pressure, and at the required rate. Maximum heat produced by the fuel in the furnace should be utilized for economy. The boiler should be easily accessible for maintenance and inspection. It should rapidly meet the changes in load. Boilers types. According to the method of water circulation, natural circulation boilers. The water is circulated by natural convection currents caused by the temperature difference. Examples: Lancashire boiler. Forced circulation boilers. The water is circulated by a pump driven by a motor. Examples: Lamount and Velox boiler. Boilers types according to the flow of water and hot gases. Fire tube or smoke tube boiler. In fire tube boilers, hot gases pass through the tubes which are surrounded with water. Examples: Cochrane, Lancashire, and locomotive boilers. There may be single tube as in the case of Lancashire, or there may be a bank of tubes as in a locomotive boilers. Water tube boiler. In water tube boilers, water circulates through a large number of tubes and hot gases pass around them. Examples: Babcock and Wilcox boiler. Boilers types according to the axis of the shell. Vertical boilers. Axis of the shell is vertical. Example: Cochrane boiler. Horizontal boilers. Axis of the shell is horizontal. Example: locomotive and Lancashire boiler. According to the application, stationary boiler which is installed permanently on a land installation. Example: Cochrane boiler. Mobile boiler. A marine boiler is a mobile boiler meant for ocean cargo and passenger ships with an inherent fast steaming capacity. Boilers types according to the steam pressure developed. Low pressure boilers. The pressure of steam produced is less than 80 bar. Examples: Cochrane and Lancashire boilers. High pressure boilers. The pressure of steam produced is more than 80 bar. Examples: Babcock and Wilcox boiler, Lamont boiler, and Benson boiler. According to the location, position of the furnace or method of firing. Internally fired boilers. The furnace forms an integral part of the boiler structure. Examples: Lancashire, Cochrane, and locomotive boiler. Externally fired boilers. They have a separate furnace built outside the boiler shell and usually below it. Examples: Babcock and Wilcox boiler. Boilers. Cochrane boiler. Cochrane boiler is one of the type of low pressure boiler. It is a vertical type multitubular internally fired fire tube boiler having a number of horizontal fire tubes. Maximum evaporative capacity is 4000 kilograms of steam per hour. Maximum pressure of steam is 10 bar. Cochrane boiler consists of cylindrical shell, grate and ash pit, firebox, furnace, flue pipe, fire tubes or flue tubes, combustion chamber, chimney, manhole, damper. Boilers. Cochrane boiler layout. Boilers. Cochrane boiler. Cylindrical shell. The cylindrical shell is vertical. It is hemispherical on the top, which forms the steam space. Grate and ash pit. Grate is placed at the bottom of the furnace where coal is burnt. Ash pit is provided below the grate for the collection of ash. Firebox furnace. It is also dome shaped like the shell so that the gases can be deflected back till they are passed out through the flue pipe to the combustion chamber. Flue pipe. It is a short passage connecting the firebox with the combustion chamber. Free tubes or flue tubes. A number of horizontal fire tubes are provided, thereby the heating surface is increased. Boilers, Cochrane boiler, combustion chamber. It is lined with fire bricks to prevent overheating of the boiler. Hot gases enter the fire tubes from the flue pipe through the combustion chamber. Chimney. Chimney is provided for the exit of the flue gases to the atmosphere. Manhole. It is provided for inspection and repair of the interior of the boiler shell. Damper. Damper is provided in the chimney. Boilers. Cochrane boiler. Working. Coal is fed into the grate through the fuel door and burnt. Ash formed during burning is collected in the ash pit provided just below the grate. The ash is then removed manually. The fire brick layer prevents the overheating of the boiler shell. The hot gases from the grate pass through the flue pipe to the combustion chamber. The hot gases from the combustion chamber flow through the horizontal fire tubes and transfer the heat to the water by convection. The flue gases coming out of the fire tubes pass through the smoke box. From the smoke box, the gases are exhausted. Smoke box is provided with a door for cleaning the fire tubes and smoke box. Dampers controls the waste flue gases leaving the chimney. When it is partly closed, the amount of waste gases leaving the chimney will be reduced. Hence, the quantity of air entering the grate will also be reduced. This results in reduction of fuel burnt and obviously reduction in steam generation. Thus, the damper controls the rate of steam generation. PA. Pressure gauge. This indicates the pressure of the steam inside the boiler. Water gauge. This indicates the water level in the boiler. The water level should not fall below a particular level, otherwise the boiler tubes may burn out. Safety valve. The function of the safety valve is to prevent an increase of steam pressure in the boiler above its normal working pressure. Steam stop valve. It regulates the flow of steam supply from the boiler to requirements. Blow off valve. It helps to remove the salt deposits and other impurities like mud accumulated in the bottom portion of the boiler shell. Fusible plug. It protects fire tubes from burning when water level falls abnormally low. Boilers. Cochrane boiler. Advantages. The dome shape of the furnace causes the hot gases to deflect back and pass through the flue. The unburnt fuel, if any, will also be deflected back. Spherical shape of the top of the shell and the firebox gives higher area by volume ratio. It occupies less floor area and is very compact. Construction cost is low. It is well suited for small capacity requirement. Disadvantage. Capacity is less because of the vertical design. Boilers. Locomotive boiler. Locomotive boiler is a horizontal multi-tubular internally fired fire tube boiler. Steaming rate is 7000 kilograms per hour. It is used in railway engines, etc. In railways, the use of locomotive steam engine is being reduced gradually. It is replaced by diesel engines. A locomotive boiler consists of horizontal cylindrical shell or barrel, firebox, smoke box, fire tubes and water tubes, fire hole, grate, steam dome, headers, chimney, damper. Boilers. Locomotive boiler, LO, barrel. The shell or barrel is cylindrical in shape of 1.5 meters in diameter and 4 meters in length. It is fitted to a rectangular firebox. Firebox. The firebox is at the right end of the boiler. It forms the furnace. Smoke box. The smoke box is at the left end of the steam shell. Fire tubes, flue tubes, and water tubes. The steam barrel consists of fire tubes and water tubes. Flue gases flow through the fire tubes. Fire hole. The fuel, that is coal, is fed into the barrel through the fire hole. It is burnt on the grate which slopes towards the left side. Grate. Grate is placed at the bottom of the firebox where coal is burnt. Steam dome. It is fitted at the top of the steam barrel where the steam will be collected. Boilers. Locomotive boiler. Headers. Headers are rectangular boxes. There are two headers, namely superheated steam header and wet steam header. Chimney. The hot gases from the smoke box are discharged to the atmosphere through a short chimney. The height of the chimney is kept low so that when the locomotive is passing under a bridge, it does not hit against the top. Damper. Function of the damper is to control the quantity of air entering the firebox. Boilers. Locomotive boiler. Working. Fuel, that is coal, is introduced into the boiler furnace through the fire hole. The grate is fitted in an inclined position for charging the coal into the furnace. A fire brick arch is fitted to the furnace above the grate. This arch deflects the flue gases, causing them to come in contact more thoroughly with the whole heating surface of the furnace. The flue gases from the furnace pass through the flue tubes to the smoke box. Flue gases from the smoke box are led to the atmosphere through the chimney. Due to the continuous flow of hot gases from the firebox to fire tubes, water surrounding the tubes becomes more and more heated and wet steam is produced. The wet steam enters the wet steam header. Boilers. Locomotive boiler. Working. To remove the moisture in the wet steam and thereby to increase the temperature of steam, it is superheated. From the wet steam header, steam flows through superheated tube provided in the big fire tube. The superheated steam is accumulated in superheated steam header. It is then led to the engine cylinder. Inside the steam dome, there is a steam top valve in the regulator. This valve is regulated by a regulating rod to allow the required quantity of steam to pass. Regulator is operated by the driver from the cabin by a hand wheel. A blast pipe is provided at the bottom of the smoke box. The exhaust waste steam from the engine cylinder enters the blast pipe and flows out, expanding with a high velocity. Boilers. Locomotive boiler. Working. Due to the expansion of waste steam, a partial vacuum is created within the smoke box. This vacuum improves the movement of waste flue gases from within the smoke box through the chimney. This vacuum also draws in atmospheric air through the fuel in the furnace. The boiler is fitted with a pressure gauge, safety valve, water level indicator, whistle, fusible plug, blow off cock, manhole. Boilers. Babcock and Wilcox. Babcock and Wilcox boiler is a horizontal externally fired water tube boiler. In this, water is circulated inside the tubes and hot gases flow over the tubes. Babcock and Wilcox boiler consists of water and steam drum boiler shell, water tubes, uptake header and downtake header, grate and furnace, baffles, mud box, two inspection doors. Boilers. Babcock and Wilcox boiler diagram. Boilers. Babcock and Wilcox. Water and steam drum boiler shell. One half of the drum is filled with water. Steam remains in the top half of the drum. It is about 8-meter length and 2-meter in diameter. Water tubes. Water tubes are placed between the drum and the furnace in an inclined position at an angle of 12 to 15 degree to promote water circulation. These tubes are connected at right angles to the uptake header and downtake header. Uptake header and downtake header. Drum is connected at one end to uptake header by short tubes and at the other end to downtake header by long tubes. Grate and furnace. Grate and furnace are provided below the uptake header. Coal is fed to the grate through the fire door. Baffles. The fire brick baffles, 2 in number, are provided to deflect the hot flue gases. Boilers. Babcock and Wilcox. Superheater. The boiler is fitted with a superheater tube of U shape. It is placed just under the drum and above the water tubes. Its upper box is connected to a vertical tube, the top of which is situated in the steam space. Its lower box is connected to stop valve. Mud box. Mud box is provided at the bottom end of the down corner. 2 inspection doors. These are provided for cleaning and inspection of the boiler. Damper. Damper is used to control the steam rate. Boilers. Babcock and Wilcox. Working. A constant water level is maintained in the boiler drum. Coal is fed to the grate through the fire door and is burnt. There is a slow moving chain grate on which the coal is fed from the hopper. By using the moving grate, the rate of fuel burning is controlled by changing the thickness of the coal bed and also by changing the speed of the moving grate. Flow of the gases. The hot flue gases from the furnace rise upward and pass across the left side portion of the water tubes. The baffles deflect the flue gases. Hence, the flue gases travel in a zigzag manner. That is, the hot gases are deflected by the baffles to move in the upward direction over the water tubes and along the superheater. The flue gases finally escape to the atmosphere through a chimney. A damper is fitted to regulate the flue gas outlet. Boilers. Babcock and Wilcox. Working. Water circulation. Water descends into the downtake header. It flows upwards in the inclined water tubes, then in the uptake headers, and finally to the drum. That portion of the water tubes which is just above the furnace is heated comparatively at a high temperature than the rest of it. Water, its density being decreased, rises into the drum through the uptake header. Here the steam and water are separated in the drum. Steam, being lighter, is collected in the upper part of the drum. The water from the drum comes down through the downtake header into the water tubes. A continuous circulation of water from the drum to the water tubes to the drum is thus maintained. The circulation of water is known as natural circulation. The mud or sediment in the water is collected in the mud box. It is blown off times to time by means of a blow off cock. Boilers. Babcock and Wilcox. Working. Superheating. Steam is taken from the steam space of the drum through a tube to the superheater. Steam is superheated in the superheater as it receives additional heat. From the superheated steam goes to the stop valve and finally to the turbine. Boiler mountings. Pressure gauge and water level indicator are mounted on the boiler at its left end. Steam safety valve and stop valve are mounted on the top of the drum. Boilers. Babcock and Wilcox. Salient features. Its overall efficiency is higher than a fire tube boiler. The defective tubes can be replaced easily. All the components are accessible for inspection even during the operation. The draft loss is minimum compared with other boilers. Steam generation capacity and operating pressure are high compared with fire tube boilers. Normally, the furnace is provided with a moving chain grate. By changing the speed of the moving chain grate, the rate of fuel burning can easily be controlled. The water tubes are kept inclined at an angle of 10 to 25 degree to promote water circulation. Lancashire boiler diagram. The diagram shows the front view, top view and the left side view of the boiler. Boilers, Lancashire. Lancashire boiler is a stationary, horizontal, internally fired natural circulation fire tube boiler. It can generate steam at the rate of 9000 kgs per hour at a pressure of 15 bar. Lancashire boiler consists of horizontal cylindrical shell, internal flue tubes, furnace tubes, side flues and bottom flue, grate, furnace door, fire bridge, dampers. Boilers, Lancashire, horizontal cylindrical shell. It is placed in horizontal position over a brickwork. It is partly filled up with water. The water level inside the shell is well above the internal flue tubes. A Lancashire boiler may have cylindrical shell of diameter 2 to 3 meters and of 8 to 10 meters length. Internal flue tubes. Internal flue tubes are also known as furnace tubes. Two internal tubes extend from one end to the other end of the shell. These flue tubes are connected to the grate at their front end. An enclosed chamber is built for each of the flue tubes at the rear end of the boiler shell. Boilers, Lancashire, side flues and bottom flue. There are two side flues and one bottom flue outside the shell. These flues are made of ordinary brick lines with fire bricks on their inner faces. Side flues are connected at the rear end to a common rear passage which is connected to the chimney flue. Internal flue tubes are connected to the bottom central flue. Bottom flue in turn is connected to the side flues. Grate. The grate is provided at the front end of the internal flue tubes. Furnace door. Coal is fed onto the grate end through the furnace door. Boilers, Lancashire, fire bridge, FB. It is made of brickwork. It is built at the end of the grate. Its purpose is to prevent the flow of coal and ash particles into the interior of the flue tubes. Otherwise, the coal and ash particles carried with gases may settle down as deposits on the interior of the flue tubes. Thus, these deposits reduce the heat transfer from the flue tubes to the water surrounding the tubes. Dampers D1 and D2. Dampers are in the form of sliding doors. These are provided at the end of the side flues. Their function is to regulate the flow of gases from the side flues to the chimney flue. Thus, the dampers regulate the combustion rate and thereby the quantity of steam generated. Boilers, Lancashire, working, water circulation. Boiler shell is filled with water to 3/4 of its volume so as to submerge both the internal flue tubes. The remaining space above water surface is the steam space. Path of hot flue gases. The fuel is fed through the fire door onto the grate and is burnt. The hot flue gases leaving the grate move along the length of the internal flue tubes from the front end up to the rear end of the shell. As these hot gases pass through the flue tubes, heat transfer takes place from the hot gases to the water through the valves of the flue tubes. Note that the hot gases emerge from both the flue tubes into the respective rear enclosed chambers. Then, from the rear enclosed chambers, the hot gases flow downwards to the bottom flue from its rear end to the front end. This results in the heat transfer from the hot gases to the water through the bottom portion of the boiler shell, which is exposed to the bottom flue. Boilers, Lancashire, working. Then the flue gases divide into two streams at the front end of the shell and pass to the side flues. Thus, the two sides of the boiler shell exposed to the side flues are heated. Passing along the two side flues, the heat gases travel up to the rear end of the boiler to the chimney. Then the flue gases are discharged into the atmosphere through the chimney. Dampers. Dampers control the flow of hot flue gases and regulate the combustion rate of the fuel as well as the steam generation rate of the boiler. Dampers control the draft. The object of draft is to ensure complete combustion of coal by supplying quantity of air through the fuel. Boilers, Lancashire. Boiler mountings. The boiler is fitted with necessary mountings. Water level indicator and pressure gauge are fitted at the front. Steam stop valve, safety valve, high steam and low water safety valve and manhole are fitted on the top of the shell. High steam and low water safety valve. It is mounted over the low water alarm apparatus. It is a combination of two valves. One valve blows off steam when the working pressure of steam exceeds the design value. The other valve blows off steam when the level of water falls below the normal level. Blow off cock. It is placed below the front end of the shell for the removal of mud and sediments. It is also used to empty water in the boiler during inspection. Fusible plug. It is placed on the top of the internal flues just above the grate. It prevents overheating of the boiler tubes by extinguishing the fire when the water level falls below the required level. Manhole. It is provided at the top of the shell for the purpose of periodical inspection and repair. Boilers, Lancashire. Salient features. The arrangement of flow of flue gases in Lancashire boiler increases the heating surface of the shell to a large extent. It has a very good steaming capacity. Coal of inferior quality can be used in this boiler without any operational defects. Superheater can be easily incorporated into the system at the end of the internal flue tubes. Thus, overall efficiency of the boiler can be increased. Feed water used does not require strict treatment before use in the boiler shell. Low initial cost. Its maintenance is easy. Due to moderate working pressure and slow evaporation rate, it is excellent to supply steam to process industries like paper mills, sugar mills, chemical industries, etc. Advantages of water tube boiler over fire tube boilers. Continued. Safety boilers. Bursting of one or two water tubes does not affect the boiler very much with regard to its working. Hence, water tube boilers, sometimes called as safety boilers. But bursting of flue tubes in a fire tube boiler causes serious problems. Transportation. The different parts of a water tube boiler can be separated. Hence, it is easy to transport. Space required. For a given power, water tube boiler occupies less space than that of fire tube boiler. Thermal power plants. It is suitable for use in thermal power plants. Advantages of water tube boiler over fire tube boilers. Steam pressure. Steam can be generated at very high pressure in water tube boilers. Heating surface. In water tube boilers, water is contained in a large number of tubes. Hence, heating surface is more than that of fire tube boilers. thus evaporation rate increases. Water circulation. A good and rapid circulation of water can be made. Variation of load. Circulation of water is more positive in water tube boilers. Steam can be raised quickly than is possible with a fire tube boiler. Hence, it can be used for variations of load. Heat transfer. The hot gases flow almost at right angle to the direction of water flow. Hence, maximum amount of heat is transferred to water. Disadvantages of water tube boiler over fire tube boilers. Water treatment. Water tube boiler is not suitable for impure and sedimentary water as a small deposit of scale may cause the overheating and bursting of tubes. Hence, water treatment is very essential for water tube boilers. Feed water supply. Failure in feed water supply even for a short period is liable to make the boiler overheated. Hence, the water level must be watched very carefully during operation of a water tube boiler. Maintenance cost. Maintenance cost of water tube boiler is high. Initial cost. Initial cost of water tube boiler is more than that of fire tube boiler. Mobile purpose. Water tube boilers are not suited for mobile purpose.